Every time Netflix suggests a movie you end up watching, or your GPS routes you around a traffic jam, or your bank flags an unusual purchase, artificial intelligence is working quietly behind the scenes. But when most people hear the term AI, they picture something entirely different. They imagine highly advanced, conscious robots operating with minds of their own. So, what actually is this invisible system curating so much of our digital lives, and how close does it come to human thought? Before we can understand how machines process the world, we have to look at the baseline for how our own intelligence operates. Imagine you're at a park and you temporarily lose sight of your dog. To find him, your brain instantly engages a specific set of problem-solving skills. The first step is visual identification. You scan the area, filter out the trees and the playground equipment, spot an animal, and quickly determine whether it's your specific dog or someone else's. Next comes strategic planning and context. If it starts raining, and you know your dog hates getting wet, you adapt your search to focus entirely on shaded and covered areas. Artificial intelligence is simply humanity's attempt to program a machine with those exact capabilities. It is writing code that allows a computer to identify objects, make a plan, and adapt to changing conditions. By establishing this human baseline, we have a ruler. We can use it to measure exactly where technology currently stands on the progression ladder of intelligence. The biggest difference is how we learn. The human brain absorbs varied experiences over time, while AI trains by crunching massive data. AI is a super-fast calculator, quick at specific tasks, but it hits a hard boundary, lacking flexible context. The lowest rung on this ladder of machine thought is what researchers call reactive machines. These systems operate entirely in the present moment, reacting to current inputs without any memory of the past. In the late 1990s, an AI system defeated world chess champion Garry Kasparov, serving as the ultimate example of a reactive machine. IBM's Deep Blue supercomputer was brilliant at calculating the exact positions on the chessboard to predict optimal moves, but it could not store past mistakes to inform its future decisions. Even world-beating computational power has a strict ceiling. If a system lacks the memory to learn from history, it cannot evolve beyond its initial programming. The next step up the ladder introduces limited memory AI. These systems use a temporary bank of past experiences to improve their real-time decisions. Self-driving cars rely entirely on this capability. They actively track recent past data, monitoring pedestrians, steep roads, and cyclists in real time to execute safer driving choices. All of the current technologies we interact with, including systems with limited memory, fall under the umbrella term of narrow AI, or weak AI. The core limitation is hyper-specialization. It operates like a superhero with exactly one power. It executes its task flawlessly, but cannot function outside those rules. Every piece of AI technology available to the public today, from your phone's voice assistant to the most advanced generative chatbots, remains strictly narrow AI. Our current technology processes tasks at astonishing speeds, but it has not yet crossed the threshold into true, flexible human comprehension. To bridge that gap, technology would have to achieve general AI and crack what researchers call the theory of mind. This milestone requires a machine to process the world exactly as we do. It would need to understand cultural nuances, interpret inside jokes, and recognize human emotion across an unlimited range of tasks. Achieving general AI would mean retiring the concept of the machine as a rigid tool. The system would transition into an entity equipped with a complete, independent understanding of the world. Beyond that lies the final, theoretical peak of machine evolution, super AI, a state where systems achieve complete self-awareness. The core threat in this scenario is an intelligence that can continuously redesign itself at an ever-increasing rate, eventually scaling far beyond human control or comprehension. This existential risk occupies modern visionaries. Physicist Stephen Hawking explicitly warned that the development of full artificial intelligence could eventually supersede humanity. Tech leaders like Elon Musk have echoed those exact concerns, pointing out the inherent dangers of creating self-aware, rapidly evolving systems. But returning to the present reality, the AI we use today is not a cinematic villain. It is a highly specialized, mathematically driven tool working quietly behind the scenes to optimize daily tasks. By understanding the strict limits of narrow AI, we can master the powerful systems we have today and safely navigate our path toward the theoretical machines of tomorrow.